Okay, so how can we add these up in an arithmetic series without, writing them all out? So a story is told about Gauss, famous mathematician, and he lived a long time ago. He was like in grade school or something, and his teacher wanted to keep him busy, and so he said, here, go add up the numbers from 1 to 100. And he thought he'd keep Gauss busy for a while, but Gauss quickly saw a pattern. So he knew he was going 1 plus 2 plus 3 plus up to 100. And he noticed that if he took 1 plus 100, and then the term before that would be 99, right? 2 plus 99, and the term before 99 is 98. 3 plus 98, all of those were 101, right? And that was going to keep happening in that series. So if he took half the number of terms, so he has all these pairs, so if he took 50 terms, 50 pairs, and they were each 101, he could get the answer. So he comes up with the answer really quick. I'm sure his teacher was disappointed that it didn't take him more time. But that's the answer. Okay, now this leads us to a formula. And so the formula for, if you have an arithmetic series, then S sub n, so it depends on how many terms you're adding up, it's equal to n times the first term plus the last term over 2. And that's the formula, so put that on your note page, and then we'll show you how to use it. It says find the sum of each arithmetic series. So this is like finite, right? Like there's a first term, so that's a sub 1. There's a last term, that's a sub n. Then we have to count how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms here, so n is 10. And now we can use that formula that I just scrolled up on. Okay, so it's going to be 10 times 5 is the first term, the last term is 32, and we're dividing by 2. So it's going to be 5 times, let's see, 37, and what's that? 165? No, not 165. Too early in the morning for me. 185. Whoops. 185. Okay, so I'll just write it over here. Yeah, that looks right. Okay. So there's that one. Now we'll go to another one. Okay, so they don't list all the terms for us, do they? We know the first term and we know the last term, right? Okay, so we know this is a sub 1. And then somehow we're getting down here at negative 50. That's a sub n. But what is n? That's the question. Well, do we know the common difference? It's arithmetic, right? So 20 to 15 to 10, the difference is negative 5. So remember that formula we had back in the last section, that a sub n is equal to a sub 1 plus d times n minus 1? Well, then we could figure out what d is. We could figure out how many terms there are. So we know the last term. We know the first term. We know d, which is negative 5, times n minus 1. Okay, so negative 50 equals 20 minus 5n plus 5. So that's going to be, I'm going to run out of room here, negative 50, 25 minus 5n. So if I subtract the 25, so that's what? Negative 75 equals negative 5n. Divide by the negative 5. I should get a positive number for n, right? N equals 15. Okay, so there are 15 terms that we're going to add up. Now we can use the sum formula. So S sub 15 is going to equal 15 over 2, oops, times a sub 1, which is 20, plus a sub n, which is negative 50. Okay, so what is that going to equal? Well, 15 times negative 30 over 2, which that's going to be 2 goes into 30 15 times, so negative 225, I'm going to say, for the sum. Is it okay that the sum is negative? Yeah, it looks like you're going to have a bunch of negative terms, right? If you have 15, most of them are going to be negative. You're going to negative 50. Okay, so now let's look at this summation here that we want to add up. So we can figure out the terms. So let's just do a couple of them. 3 times 1 minus 8. And then the next term would be 3 times 2 minus 8. Oh, I don't know why I put the parenthesis there. And then I guess I could put these in brackets. Maybe that would be helpful. So that's the first term. And here's the second term. They told us it was arithmetic. We could keep going just to show one more, but I'm going to skip and go to the last term, which is going to be 3 times 12 minus 8. Okay, so 3 minus 8 is going to be negative 5 for the first term. And then 6 minus 8 is negative 2. Okay, plus, and then the last term is going to be 36 minus 8. So what's that? 28. Now, I'm doing a summation. Do I know how many terms there are? Yeah, it's going from 1 to 12, so n must be 12. The first term, I know, negative 5. The last term, a sub 12, is 28, so we figured that out. And now we can use that sum formula. S sub n equals n times a sub 1 plus a sub n over 2. So my n is 12. My a sub 1 is negative 5. My a sub 12 is 28. And then this is all over 2. So I just have to do a little more work. This is kind of a long video. 2 goes into 12 6 times. 6 times, okay, negative 5 and 28 is going to be 23. So whatever 6 times 23 is, 138, I'm going to say. Probably with this being early in the morning, I should just grab a calculator and make sure I'm doing it right. Okay, there we go. All right, so that's how you use the summation formula for an arithmetic series.